267330. You have another 2 weeks, then your midterm test will be on 12th August. So today I will cover this chapter 6, and then this chapter 6 is actually not important for your exam. But I still will go through the chapter 6. After I go through the chapter 6, I will discuss some past year questions. Okay. Okay, chapter 6 is on the transport level security. So what is transport layer? If you have take the network subject, it's actually the UDP and TCP packets. So how you make sure the packet is secure? So you will learn in this chapter 6. Okay, web security consideration. You know website, right? www. So what is the possible trade in this website? What kind of trades you have heard before? So the first one, if you did not apply this integrity, there's a possible modification of the data. You know what is modification of the data? Trojan horse browser is the browser looks safe and the function looks accurate, but it is actually a fake website or a fake application with the uncertain with harmful things in the application. This is known as Trojan horse browser. Or modification of memory and modification of message traffic in transit. So this is integrity. So how you make sure the file is integrity? How you make sure this? So you can apply this cryptographic checksum or the hash function. The second thing is if you did not apply this confidentiality for this website, what will happen? If you did not encrypt the data, what will happen? So there's a possible the thief of info from the server or the client, or they will get the info about the network configuration and so on. So you will lose your information or loss of privacy if you did not encrypt the data. So how you make sure the confidentiality is you can apply this encryption or web proxy. Okay. The third one, the type of trade is denial of service. What is denial of service? It means that there's a floating missing with the bogus request. For example, there's a lot of traffic reach at the website at the same time. So when there's a suddenly increase, so what will happen? So there's a disruption and so on. The website is down and so on. So how you protect this denial of service? It's difficult to prevent. But how you can prevent? From this denial of service, from the things I know is actually, the company will actually look at the IP address. So when the same IP address is keep on coming at the same time and keep out a lot of traffic, they can block this IP. So this is how you can prevent this denial of service. So the fourth thing, authentication. What is authentication? So if you did not provide this authentication, that what will happen? The things will happen is the impersonation of the legitimate user. What does it mean? It means that an intruder or a hacker become impersonate, pretend to be the user and access to the account. So how you can prevent this? You can apply these cryptographic techniques. So this is the type of trade on the website. Example of the trade and how you're going to prevent it. So what is SSL? What is TLS? So you can see from this slide that apply the network layer, transport layer, and application layer. This is actually the networks layer. So for the networks layer, is actually consists of the router devices. So how you make sure the traffic or the packets that is sending from one to another router is secure? How you make sure the packet is secure when it is sending out? So in this layer, you can use this Internet Protocol Security. So it is known as IP security. It's actually the Internet Protocol Security to encrypt your packets to make sure when it is sending out, it is secure. So transport layer is for the TCP and UDP packets. How make sure the packet is secure? Normally for this HTTP, you apply in this HTTP, FTP, SMTP. For the website, for the browser, have you seen the word SSL before? So it's actually the security applied to this HTTP to protect the packets. And for the application layer, what is application? The example application is like the electronic transaction. Electronic transaction is like the online transaction, one of the application, or the email is one of the example application. So you have learned this email, how you secure the email. You can apply this PGP or this S/MIME to secure your email, to provide it the confidentiality in integrity to the email and also electronic transaction. So I already explained this. IP security is actually transparent to the end user and application and provide a general purpose solution. And this is the SSL and TLS. Normally, you will use this in the Internet Explorer or the browser and come equipped with this SSL. This applies for this HTTP to protect your packets. For example, you can find this in the Internet Edge or the Mozilla Firefox. You can see the security version and so on. And this part for the application layer, this part is the application specific security services. They are embedded within a particular application. So for this SET, is applied to this electronic transaction. And for this PGP or S/MIME, this one can apply to the email. This version and so on, I will not explain now. The SSL version 3 was originated by this Netscape. If you're interested, then you can go and read the history for this now. Okay, SSL TLS is designed to make use of TCP to provide a reliable end-to-end secure services. So it is a two-layer protocol. The first layer is used in the management of SSL exchange. What does it mean? I will cover this one. This one will the SSL handshake protocol. And the second layer, this is the basic security to various higher level protocol. This is a SSL record protocol. So what is SSL handshake protocol? It is used in the management of SSL exchange. So this is the handshake protocol operation. This is the client. Okay. This is the client, and this is the server. Can you see? Cannot, it's okay. When client want to connect to server, this is known as the section. These are SSL handshake protocol. They got two important concepts for this SSL. One is SSL section. Another one is SSL connection. So SSL section is association between client and server. And these sections are created by this handshake protocol. And section define a set of cryptography security parameters which can be shared among multiple connections. So this is an association between client and server. Sections are created by this handshake protocol. Association between client and server are created by this handshake protocol. When the client wants to associate with the server, first thing client will send out the hello packet to the server. Then the server will reply hello. Why they want to send out the hello message is to the client is to make sure the server is there. The server is there. After confirm that, then they will start exchange the certificates and also the key. They will start exchange the. You can see the server will send the certificates and the key to the client. At the same time, the server will request the certificates and also the key from the client. Then the client will send back the certificate and key to the server and also change the cipher spec and then finish. Then it's able to connect. So this whole process is known as SSL section. It's created by this handshake protocol. And this SSL section can use for multiple SSL connection. Okay. For example, this is the it can be shared among multiple connections. So SSL connection is a transport that provides a suitable type of services, for example, peer-to-peer relationship. So every connection is associated with one section. All the connection is associated with one section. It is to connect peer-to-peer. So a section state is defined by the following parameter. This is the section ID, means the section ID, section identifier. Every section there's a section ID. Means the whole section may be section number 1, section number 2, and so on. So number 2 is the peer certificate. Peer certificate, this certificate is X.509 certificate. Then compression method is to compress the data into smaller size, and then cipher spec this consists of the encryption data and also the hash algorithm used for the MAC calculation. And the master secret is actually 45-bit secret shared between the client and the server. This is actually the secret key shared between the client and also the server. Because they need a key to encrypt the data. So they will share this secret key first, then they will use the public and private key to encrypt the secret key. And the secret key is used to encrypt the data. This is known as master secret. In this handshake protocol, just now you will see, they will share the key, they will send the secret key. Server will send to client, client will send to the server. Because they need this key to encrypt the data. And this cipher spec is actually attached these MAC codes. If you still remember, message authentication code is to provide you the integrity. Okay, so this SSL, this is actually to provide you the security in these packets. So connection state is defined by the following parameter. So server and client random. This is choosing the random number between the server and client. And server write the MAC secret. This means that server will write the MAC value to the packets. And then client will write the MAC secret to the packet. Then server write the key and client write the key. It's actually a symmetric encryption key for the data encrypted. You can ignore all this. This chapter is not important. So just now I said that there's a provide two services for SSL TLS connection. Okay, you still remember the SSL TLS record protocol? The top one is the handshake protocol, and the bottom one is the SSL record protocol. So what the services were provided by this record protocol is confidentiality and integrity. Confidentiality means that it will encrypt the payload. It will using the shared secret key and encrypt the SSL packet or the data. And then message authentic integrity is actually to form a MAC. They will use the shared key and form this MAC and attach this MAC to the payload's data. Then you can prove the data confidentiality and integrity. Okay? You will check is there anyone modified it or the integrity of the data. So the operation for this record protocol, the first step, this is your application data. How we measure the confidentiality and integrity for this data? First step is you will divide this data into fragments, means that divided into smaller size, smaller parts, multiple parts. Then compress the fragments. Compress means that make it smaller size. Then adding the MAC to the data. This MAC is actually to check the integrity of the data. After that, you encrypt the whole things. This is the confidentiality. After encrypting the whole things, then you adding the header, then only transfer to the next user. This is the operation for this record protocol. Actually, you can take this picture from your slide. You just put it in the slideshow. Then you can see the whole things. So this is the format. So it will encrypted this part. encrypted the plain text and also the MAC value. Other fragments that it will compress, after that it will add in, and then encrypted. This change cipher spec protocol and alert protocol is when there's an error happens. The client or server, if detect the error, they will put this alert here. So the client and the server know that there's alert. So there's actually two levels. One level is alert. Alert means that it's still functioning, but there's alerts to the client or the server. And this change cipher spec protocol is this protocol consists of a single message, only the single byte, which consists of a single byte with a value of 1. So the sole purpose of this message is to cause the pending state to be copied into current state. Means that after the whole process from the handshake protocol, after you are changing the key and so on, so the client or the server will trigger this change cipher spec protocol. So it's actually lets the server or client know that the process already completes. Let the client or server know that the process is complete by the client. And once the server done, they will trigger this change cipher spec protocol, so they know that the process is completed. So this is a repeated slide just now. So the two services is actually confidentiality and integrity. Confidentiality means that you can encrypt the payload. Integrity means that you're adding this MAC value to the packet. Okay, come to the handshake protocol. The handshake protocol is just now the two lines here and with the client and also the server. When client want to connect to the server, there's a few steps. They will sending out the hello packet, hello message, and the server reply it. Then the server will send the certificate and also the key to the client and the request the key and certificate from the client. Then the client will reply back. And then the connection is established. This is the handshake protocol. So this is the step. Step 1 is to establish the security capability. So it will initiate a logical connection and establish the security capability will be associated with it. So they will exchange this hello message between the client and also the server. So this is the phase 1. They will exchange the hello message. Then phase 2 is they will server authentication and key exchange. So how the server authentication, how the client do this server authentication is, the client will check on this X.509 certificate. The server will send this X.509 certificates to the client and also sending the key to the client. So the client will authenticate the server. After client receive authenticate the server, now is the time the client authenticates the server. So client authentication and key exchange. So client will send this certificate to the server and also the key to the server, and then the server will validate it. Okay. After all done, all authenticated, all encrypted, the final stage is finished. So the connection is setting up. So you can connect from the client to the server now. You can exchange the message. Any question? Handshake protocol. Okay, what is secure cell protocol? Secure cell protocol. Have you heard the Telnet before? Telnet. Telnet is a remote access, but without security features. So if you want to make sure the remote access to be secure, you can use this SSH, Secure Sound Protocol. So this is protocol is used for the secure network communication. Previously, they are using this Telnet, but there's no security features for you. So this SSH fixes the number of security flow in the original scheme. So this is secure cell protocol stack. You can see that under this SSH transport layer protocol is actually provide you this authentication, confidentiality, integrity to the packets. So this is how they establish the connection between the client and server for this remote access. So this is the same things. You have the payload, you compress it, and you encrypt the things, and you adding the max, then send it out. So this part is secure electronic transaction. It's also known as SET. So what is SET? So this is actually an open encryption and security specification to protect credit card transaction on the internet. So it's actually to protect the credit card transaction on the internet. The example company is like the MasterCard, Visa, and so on. So this is not the payment system, it's actually a credit card transaction, is to protect the credit card transaction. It's not the payment system. So this is the SCT participant. It consists of the card holder. This is to secure the transaction, it's not the payment system. So it consists of the card holder, the merchant, issuer, acquire, payment gateway, and this certificate authority. So if you still remember why certificate authority is actually signed on the certificate. So what is the purpose of sign on the certificate is to authenticate all the parties. So from here you can see all the card holder, issuer, merchant, and so on need to register with this certificate authority. Because to make sure this secure transaction, we need to authenticate all the participants. So all the participants in this SET need to register with this certificate authority. So from here, who is the card holder? So the card holder is the customer who own the card. So where the customer get the card is from the bank, issuer. So this is the bank. Bank will provide the card holder the cards, the credit cards. So merchant is actually the online shop for you to buy the things. So acquire is actually will link with the merchant. They will, it's like the PayPal. They will check the card holder credit card is valid or not. Does it expire or does it over limit or so on. So this acquirer will link with the merchant. After that, all the process, get the money, the acquirer will send the transaction to the merchant, and the merchant get the money, and the payment gateway. Okay, the end. So this chapter is not important for your exam. Okay, not important for your exam. But maybe for your knowledge. Have you do revision for your midterm test? The tips, because the question is not yet ready, we can go through the past year question and you get ready. Next week, if the question is ready, I will give you some chapter that's important for you to pay attention. Yeah, only 3 chapters. You want to go back already? Yes. You don't continue? No. Don't want. This is the example of past year midterm test. So the first question asks, how are you going to convert plain text to ciphertext in symmetric encryption? 2 types of operation techniques used in cryptography to convert plain text to ciphertext. Any words in your mind? Still remember the substitution? Secret recipe? What is substitution? What is substitution? Yeah, substitutes the words with another character. This is to convert from the plain text to ciphertext. Transposition, what is transposition? What is transposition? Transposition, yeah, we change the sequence. Okay. What is block cipher? What is string cipher? What is block cipher? Encrypt the entire block. The string cipher is divided into bit or bytes. Okay. Okay, can you draw out an aspect? If I ask you to draw out the substitution transposition, can you draw it out? Illustrate and explain. Okay, second question. AES does not utilize filter cipher structure. Do you agree or disagree? Agree. Yes. So how does AES run? So you will run parallelly through the 4 stages. If you still remember the 4 stages. So you need to write down and explain the 4 stages. How to enhance the security of filter cipher structure? How you enhance the security in this filter cipher structure? Yeah, key size. Increase the key size. Increase the block size. Which algorithm using this filter cipher structure algorithm? Which algorithm using this filter cipher structure? Yeah, DS3DS. So briefly explain the information that cryptanalysis attempt to discover. What cryptanalysis attempt to discover? They attempt to discover the plain text. The plain text for the data. What are the examples of attacks that adopted by the cryptanalysis? Brute force attacks, dictionary attacks, probable work attacks. What is the purpose and usage of message digest function? What is message digest function? What is message digest function? It's same meaning with the hash function. So what is the purpose and usage of this hash function? Change the to authenticate. To authenticate. So provide 2 requirements of hash function. What is the requirement? If you still remember, the correction resistance is only can be forward. It cannot reverse. Okay. Example usage of hash function. What is the usage of hash function? Huh? Password. Yes, hashing password. Correct. Hash brown. You want to continue? Okay. What is the difference between block cipher and string cipher already discussed just now? Describe three examples of attacks adopted by cryptanalysis also explained just now. To enhance the crystal cipher structure security is also already discussed just now. Okay, this formula, you still remember what is RSA algorithm? What is RSA algorithm? Asymmetric encryption, one of the algorithms use the public key to encrypt, the private key for decrypt. So if given you the ciphertext C equal to the ciphertext, you will get you will use the message is the plain text, you encrypt the plain text and modulus n, then you'll get the ciphertext. So the first question asks you to write down the formula for decryption algorithm. What is the formula for decryption algorithm? Decryption. C, start from C is encryption. You can go back to the RSA slide. I will end the class before 7, don't worry. This is the formula. To convert from the plain text to ciphertext, encryption is equal to C equal to M E modulus N. C is ciphertext, C stands for ciphertext, M equal to plain text, E encrypt modulus N. Plain text is equal to M, you want to get back the plain text, equal to ciphertext, decrypt modulus N. Okay. So if asks you to write down what is the public key formula and what is the public key and private key, you need to write down this. KU equal to bracket EN, KR equal to DN. N is encryption, D is decryption. Public key for encryption. You need the public key and modulus. If you will do this in the practical, you need to find two prime number and you need to calculate the N is equal to modulus P times Q and Euler quotient. Then you will choose one public key, then you will determine D, then this is the public key and private key. Okay? Because the basket question asks you to indicate the public key and private key used in the RSA algorithm. So you need to write down the key, public key and private key. Can you describe the four stages used in AES? Describe the four stages used in AES. Three ways how to increase the security of a crystal cipher structure is the same things. Two types of encryption algorithms that are not based on crystal cipher structure. What's the example algorithm that are not based on this crystal cipher structure? DES. Cannot RS. Without cycle structure, only DES and 3DS. Other than that, will be correct. Describe three approaches in message authentication through the use of cryptographic techniques. You can write down the hash function with the symmetric encryption, hash function with the asymmetric encryption, hash function with the secret value. Still remember the three types, the hash function. Two types of attack is same things. Block cipher, string cipher, same things. Okay, after go through the question, you know what you need to focus. The DS, 3DS, AES, comparison, the key size, block size, and also the chapter 1, because it's covered from chapter 1, 2, and 3. Chapter 1, basically you need to know the active attack, passive attacks, the example of active attacks, passive attacks, and so on. Chapter 2, most of the things just at the end there, you don't need to focus. Most of the things you need to focus. All the diagram no need. No diagram. And this key distribution, so far no need. The slide behind this all no need. No calculation, but maybe formula only, like the RSE. So chapter 3, calculation, no calculation for this Diffie-Hellman. But you need to know what is Diffie-Hellman. All these diagram no need. So you just until 69. Only 3 chapters. Okay, any question? If no, so that's all for today. Remember sign your attendance.